Now you have understood work. The second topic is energy. What is energy? How it is applicable in our day-to-day life? The capacity of an object to do work is known as energy. So the definition here, the capacity or the ability of a body. Okay? The capacity or the ability of a body to perform work is known as energy. Got it? You know about many different forms of energy like mechanical energy, chemical energy, solar energy, wind energy, correct. Then light energy, then electrical energy, atomic energy, sound energy, etc. These are the different forms of energy. How we will prove that energy can do the work? There are different examples given in your textbook. The first example is, if a pot is kept in a dark room for many days, you will find that the plant does not grow. The plant dies off because it is not able to perform photosynthesis or the life-giving activities by the use of chemical energy. Then the second example is, when you increase the volume of a music system in the room, you find that the things inside the room are vibrating. This is the example of sound energy. The third one example is, if you collect the sunlight on a piece of paper through convex lens, you will find that the paper burns. This is the example of solar energy. So any kind of energy means it is having a capacity or it is having the ability to do a work. Got it? What about the units of energy? In SI system or MKS system, you know that the unit of work is joule. The unit of work is joule. So same is the unit of energy. Then in CGS system, the unit of work is hours. So it is also same for energy, as both are related. Work and energy are correlated. So here their units are also same. In this chapter, we will study about mechanical energy and its two forms. That is kinetic energy and potential energy. There are two forms of mechanical energy, kinetic energy and potential energy. What is kinetic energy? To understand kinetic energy, three examples are given in your textbook. First one, what will happen when a fast cricket ball strikes the sun? You know that when a fast cricket ball strikes the stumps, it will throw off the stumps. Then the striker hits a coin on the carom board. So here also the striker will move the coins on the carom board. Then one marble strikes another marble in the game of marbles. Then the moving marble will hit a stationary marble and the marble will move to two different directions. So here we understand when a moving body hits a stationary object, it gives speed and direction to the stationary object. This moving body is having a form of energy, and that energy is known as kinetic energy. So, the energy possessed by an object due to its motion is known as kinetic energy. The energy possessed by an object due to its motion is known as kinetic energy. So, when kinetic energy is applied on a moving body, the moving body gains a work done on an object when the object is at a stationary position, it moves because it gains the kinetic energy. Okay, so work done on an object when the stationary object moves, it gains kinetic energy. Now we can write kinetic energy is equals to work done on the object. Okay, so this kinetic energy, we have the formula force into displacement for work, means kinetic energy is also equal to force into displacement. Now you have to understand the expression for kinetic energy. Suppose a stationary body of mass m moves due to the applied force. Okay, when force is applied, the stationary body moves in some direction, and when it moves, it gains kinetic energy. We have to find the kinetic energy obtained by this stationary object when force is applied on it. Okay, for that we have to know U is the symbol for initial velocity of the object. What is the initial velocity in the beginning? It is 0 meter per seconds. Okay, then force, capital F is the applied force. A is the acceleration gained by the object due to applied force for time t, which is in seconds. Okay, then v is the velocity obtained, or we can say the final velocity obtained by the object. Unit is meter per second, and s is the displacement occurred in the object due to this force. Got it? So here, when force is applied on a stationary object, work is done on that object. Now we the work done is equals to force into displacement. Now we have to substitute for the force as well as for the displacement. We can do this by using Newton's second law of motion. Okay? Using Newton's second law of motion, we know that force is equals to M into A. Okay? And using Newton's second kinetical equation, using Newton's second kinetical equation, we know that x is equals to ut plus half at square. This is the formula. Now u, we know that u is equals to 0 meter per second. So if I substitute, I will get this 0 plus half at square. That means s is equals to half at square. Now we can substitute the f and s in the first equation. Okay? Substitute f and s in equation 1. What we will get? Work done is equals to M into A multiplied by half at square. Got it? Now W is equals to, arrange this, you get half M. A is 2 times, so AT, both I can write in one bracket. So AT the whole square. Got it? I have just arranged this equation. Using Newton's first kinematical equation, what we have? V is equals to u plus at. But we know that initial velocity u is 0. So I can write v is equals to 0 plus at. That means v is equals to at. Or I can write v square is equals to at square. Squaring both sides. Okay? Squaring both sides. Now you can substitute this in the previous equation here. Name this equation as 2. So substitute at square as v square in equation 2. We will get, therefore, work done is equals to half mv square. Got it? Now we know that this work done was due to kinetic energy. So we get the expression for kinetic energy. Kinetic energy is equals to work done. Okay, so we can write kinetic energy is equals to half mv square. This is our expression. Remember, this equation kinetic energy is half mv square. The expression for kinetic energy you have to take down from the beginning. Okay, and you have to write this because it is asked for 3 marks question. Copy it down.